Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs. Now, we are going to learn how to find the mass flow rate and the overall efficiency of Hall thruster. Consider the BPT 4000 Hall thruster, which is an advanced electric propulsion system used in GEO satellites. Some reported values include an overall efficiency of 59% at a specific impulse of 2000 seconds with an input power of 4.5 kilowatts while delivering a thrust of 280 meganewton. During 5,800 hours of operation, the system is reported to have utilized 250 kg of xenon throughput, which represents the magnitude of the flow rate. Calculate the mass flow rate and the overall efficiency. Given data. Here, the specific impulse I suffix s is equal to 2000 seconds. And input electrical power to the thruster P suffix E is equal to 4.5 kilowatts and thrust F is equal to 280 meganewton. And the propulsive time T suffix P is equal to 5800 hours. Now we have to find out the mass flow rate and the overall efficiency. In spacecraft propulsion, Hall thruster is a type of ion thruster in which the propellant is accelerated by an electric field. Hall effect thrusters trap electrons in a magnetic field and then use the electrons to ionize propellant, efficiently accelerate the ions to produce thrust, and neutralize the ions in the plumb. Hall thrusters have flown in many Russian satellites and in the European Space Agency's Smart 1 mission. The BPT 4000 has been used by US Air Force in several missions, and Hall thrusters are presently being implemented for orbit raising and station keeping on geostationary US satellites. Higher specific impulses and some throttling capability are deemed desirable for other applications. First, let me find the mass flow rate. As we know that mass flow rate is directly proportional to the thrust. So write m dot is equal to F divided by I suffix s into G naught, where F is the thrust, I suffix s is the specific impulse, and G naught is the acceleration due to gravity, which is 9.81 meter per second square. Solve this equation with the given values. We get the required mass flow rate is 14.3 into 10 to the power minus 6 kilogram per second. Next, find the thruster efficiency. Thruster efficiency accounts for all energy losses that do not result in propellant kinetic energy. It measures how effectively electric power and propellant are used in the production of thrust. Then write eta suffix t is equal to F into I suffix s into G naught divided by 2 into P suffix E, where we know all values. They are given in the question. Now substitute those known values and simplify. We get the required thruster efficiency is 0.61. This propellant mass flow rate is very low, which is desirable for long mission durations. The calculated mass flow rate is somewhat higher than implied by the given data, likely of a lack of specificity. The calculated efficiency is somewhat greater than the quoted 59% because minor system losses have not been taken into account. Furthermore, the internal or Hall efficiency cannot be determined here because additional information is necessary. Did you know It teamed up with Microsoft co-founder. SpaceX got some extra tech world cred when Microsoft co-founder Paul Allen jumped on board in 2011, creating a joint project with a company called Stratolaunch Systems. It seems Allen and Musk want to put people into orbit using an air-powered rocket that would be fired from the back of what, if built, would be the largest aircraft ever. It has fun naming its craft. Sure, breaking through the atmosphere is serious business. But that doesn't mean SpaceX can't have fun naming its craft. In true space dog fashion, the Falcon 9 rocket was named in homage to Han Solo's blockade, running craft from Star Wars, the Millennium Falcon. The 9 represents its 9 engines. And as for the Dragon capsule, that's a nod to the general trippiness of spending hundreds of millions to reignite the space race. When SpaceX founder Musk started telling people he was building a spaceship, they wanted some of whatever he was smoking. So he named his craft Dragon, as in, Puff the Magic Dragon. It's helping inspire more astronaut dreams. Fostering the next generation of astronauts means making sure today's students are excited about science and math. SpaceX may have helped do that when it included experiments contributed by 15 American students in Dragon's payload. Students began creating the experiments in June 2010, and 779 teams made up of students from grades 5 to 12 submitted proposals.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired, and fly high.